This is a demonstration showcasing how TechSoft 3D's extensive CAD and CAE products can enable generative design workflows for additive manufacturing. The Citron Solve SDK is utilized to power the finite element analysis solver used in this demo, which is capable of reading Abacus INP files through its integration with Citron Access, an SDK for reading and writing common CAE file formats. Loads and constraints were applied to the model to locate areas of low stress. These low-stress areas identify locations where excess material can safely be removed without compromising the model's structural integrity. Results from the simulation are then passed to the open-source Python library called BSO for topology optimization. BSO refines the model by removing unnecessary elements, optimizing for weight and strength. The process is then repeated iteratively until the model's mass is reduced by 40%. After optimization, the refined model is loaded into the Citron Envision demo viewer to view the stress and strain results. Through this, we can verify that our model still meets the stress and strain tolerance criteria. At this stage, the model contains many jagged edges that are not ideal for additive manufacturing. To resolve this, the model is exported as an interoperable OBJ file format and imported into MachineWorks Polygonica, a mesh processing software development toolkit. The resulting model from the generative design process is non-manifold and has self-intersecting tessellation. Polygonica's automatic healing functions can repair the mesh so that it is watertight, manifold, and without self-intersections. Additionally, Polygonica can remesh and smooth the model to remove jagged edges, making it better suited for additive manufacturing. Once the mesh has been repaired and smoothed, one more verification step needs to be run to ensure that the modifications have not compromised the model's structural integrity. Therefore, the model is exported as an STL file and imported back into Citron Solve. Here we apply restraints and loads to confirm that the model still falls within the acceptance criteria. Through this additional analysis, the final model's structural integrity has been verified, and it can now be prepared for 3D printing. Using Hoops Exchange, the STL file is converted and imported into a Hoops communicator-based print bed preparation application so that the model can be sent off for 3D printing. The final generative design results can also be shared with interested stakeholders through an interactive 3D PDF generated by Hoops Publish. This is just one example of how TechSoft 3D's wide range of products for CAD and CAE tools can be used in a generative design to additive manufacturing workflow. For more information about our extensive product portfolio or any of the products used in this video, please visit techsoft3d.com.